Namaste, welcome to the Pragna channel. You are watching Apache Spark Masterclass Beginner Course. We are in chapter 3, episode 4. In this particular chapter, we were trying to create our first Spark application different ways. And in this episode as well, I'm going to show you something different than what we did in the last 3 episodes. Today, we are mapping out and building another program in PySpark, and I promise you are going to leave with a clear understanding of both the concepts and the code, just like we did in other episodes. We are going to answer a classic data analysis question. What are the most popular words used in the English language? We will go through reading text data, transforming it, and analyzing it all with PySpark. Stick around because there is a super practical project for anyone learning big data or Spark in general. Before writing a single line of code, let's talk about why planning matters. Think of coding like cooking. You don't want to be halfway through a recipe only to realize you are missing ingredients. The same goes for data programs. Planning saves time and avoids mistakes. So we are going to use a blueprint for our project, and the blueprint looks something like: first, read. We will read the input data. It's a plain text file. Number 2, token. We are going to tokenize each word. Number 3, clean. We will remove any punctuations and non-words, and we will lowercase everything so that we won't get duplicates. And number 4, we are going to count how often each word appears. And finally, number 5 is answer. We will return the top 10, 20, 50 or 100 most common words. So we will start simple using Jane Austen's Pride and Prejudice as our data set. But you can use any plain text you like. There is no restriction. You can use any text file you want. Every PySpark program follows a few fundamental steps, no matter the data type. You might have seen this in our last 3 episodes. First, we will ingest the data or load the data. Then we will print the schema or the structure of the data to see what structure it has. And finally, we will show a sample of the data to see if we are actually able to read data properly. We are able to parse the data properly or not. This is the invisible work in data analysis. According to Pareto's principle, about 80% of your time goes into prep and cleanup. The final visible results, only 20% of the effort. But if you put garbage in, you will get garbage out. Okay, remember that. PySpark gives us two main data structures. Do you remember them? They are RDD and data frame. RDD stands for Resilient Distributed Data Set. Think of this as a big bag of records you can process. And data frame, think of this as a table like in SQL or SQL, where each column has a type and a name. We will almost always use data frames because they are fast, flexible, feel familiar if you have ever used SQL or Pandas. Let's use PySpark data frame reader to read our data, which we have done in other examples. So if you wish to do that on your own, go ahead and do that. And let me get the file first. Here's our Pride and Prejudice file. You can see that it's a complete story. If you are interested in reading, go ahead and do that. But this is a text file we are going to use. Okay, so let's go ahead and read it. Where is my Zeppelin? Okay, what did we do first? We mentioned it's, and by the way, I'm using Zeppelin. You don't have to use it. The reason I'm using it is to save my code here so that I can put it in the class work so that you guys can do it later on. That's the only reason. You can write this code in PySpark shell as well, or you can use any other means like Jupyter. I'm just going to use Zeppelin for that purpose so that I can store them and give it to you guys as part of classwork so that I don't lose the code. Got it? Okay. Now what do we do? From PySpark dot SQL import Spark session Spark equals to Spark session dot builder dot. If you want to give the name, you can. So let me run it so that it's fine. It does not fail on me. So something is going on. It's unable to connect. Maybe it got disconnected or something. As you can see here. Let's see if there is some problem. What is this? This is not it. This is Zeppelin. Let's see. I have put my computer on sleep. Not sure if that is cause some issue. So let me, not sure if it is because of this. Let me run it again. Okay, yeah, it's because of that. So let me try to insert new and I will put my steps there. I should have used Jupyter because I have never used Zeppelin, and Jupyter has an easy way to mark this as like markdown so that it will not treat, it will not think it is code, etc. Maybe in PySpark we can maybe convert this to hash. I don't know. That's fine. I don't know how to do that here. Maybe convert this to head or something. Does it make that? Hmm, it's okay. Anyways, that's our Spark session. Then let's use it to read our file. And you can write however you want. I will say book because this is a book. Spark dot read dot. You can say format and give it as text, or you can use text as well. And then mention the location of the file. And since this is a text file, not CSV file, it doesn't have a header. So I'm not going to tell it has a header or anything like that. So let me go here. So 1342-0.txt, I'm assuming that's what the file name is. Okay. Now, what does this do? This creates a data frame, right? Now, if I run this, it won't show me anything because it created a data frame, but we are not doing anything to it. So what I will do is I will just type book and run it. Let's see what happens. Oh, sorry, never mind. I can put the PySpark here and run it, but I just feel like that's too much. Okay, it's saying it's a data frame. It has the value which is of type string. Because we haven't given it any schema or anything, it reads the entire file as just a value and the format as string, right? And this is one way to do it, but you can also do another way to get the schema out of a data frame, and that would be dot print schema, which is something that it already showed up. Now let's go ahead and run this. And you can see now it tells you that the column value is of type string when nullable equals to true. And you can also do something else as well, that would be print book d types. That's like data types, and it is telling you the data type is string and the column name is value. So you have learned a couple of ways here. We have a single column called value and it's of type string. Each row is a line from our text file. Knowing column types helps Spark optimize processing and prevents silly errors like adding a string to a number. And you might be wondering, you said there are two data structures in Spark, RDD and data frame. What are the difference between these two? Data frames are column centric, which are good for SQL like operations. RDDs are record centric, good for custom processing. Data frames are almost always the way to go because we have pretty much built functions on top of RDDs, so you don't have to go to the custom level. No matter what you write, whether it is Spark SQL, any code you write, you will use data frames. By the end of the day, it will convert them to RDDs, but we won't know it. It does it behind the scenes. And we have printed the schema, and that isn't enough. We want to see the data, isn't it? So how will you do that? Using the show command, which we were doing since forever. So let's do that again. And let me run it. Okay. You have seen this data, right? But what is happening here? You see the dots everywhere. And show displays the first 20 records, as you can see that from here. And each row is one line from the book. But this is not clear, right? If you want more control, instead of 20 rows, if you want more rows, and if you want to see the complete line instead of that being truncated, there is a command that you can use. And by the way, actually, let me put all the commands here so that I don't forget. Print schema. And what did I have? Book, right? Okay, I will put it there. And how do you do that? Do you guys remember it? Book dot show, and you can say this is Python. So the first parameter is how many rows you want. Let's go with 10. And you will say truncate equals to false, capital F, else. This is Python. Or this prints the complete line. Instead, if you only want certain number of characters, you can do this as well. Okay. So it will show you that 50. And if I say false, I mean, this one, I guess it only had that, but yeah, as you can see, it shows you everything. Instead, if I say 50, now you can see it shows you 50 records. And if I remove the number, it gives you only 20 records again. Okay. If I give 0, I'm actually that's 0 records. I don't know why I wanted to show you that, but you get the idea. And remember, use show and print schema together for a complete overview of both, looking at the columns and data types as well as data. Unlike pandas, Spark does not show data until you call an action. We learned this in the previous video. For example, like you nothing happened until you ran the show action. This is called, Sitaprakash, let me know in the comments. This is called lazy evaluation. This helps Spark optimize transformations and only process what you really need. Do you want Spark to act more like pandas and show data after every transformation? You can enable eager evaluation like this. What is it called? It's called eager evaluation. But don't worry if you skip this step. Now let's look at it. We already have our code, but let me copy this again. We can go here and clear the output. Same code I'm going to use, but I will make a small change. What is that? After you have builder, let's put something called config. In the config, I'm going to put a configuration property which is Spark SQL REPL eager eval enabled, and I'm going to tell the value of this is true. Got it? Now let's tokenize our data. Mm, Tokenizing just means splitting each line into a list of words, like turning them into tokens. That's what we are going to do. So for doing that, we need a function. So let's import that from PySpark functions. We are importing split. Okay. Let's go ahead and instead of this here, let's create this lines, and we are going to use the book data frame, and we will select. In the select, we are going to use the function split. And what does the split do? As the name suggests, it will split the line into different values based on the separator you are going to give. I'm going to give a space. So I'm telling it to split the line, but use the space as the delimiter. For example, let's assume if this is my line and I have a space between 2 and 0, so it will split 1, 0, space again seconds, dot, seconds and dot will go together, then there is a space, last space, updated space. By you can see it's splitting into words indirectly. And going to name this splitted field as line in my data frame, because my data frame needs column names. Then I'm going to say show me top 5 lines, how it looks like. Now if I run this, oh, I said 5. And this is how it's going to look like, because my first line, it turns each line into a list, and it will have this, then it had a space of start, then the space of etc. You can see that. Okay. If I had to reiterate again, we imported split from PySpark SQL functions. Then we used select to transform the value column, split each line by space, and name the new column line. Each cell is now a list or array of words, which you can see from here. PySpark offers several ways to select your columns. Correct? You have already seen here. Now let's add something to this code. We have already imported split, but let's import another function which is called call. And by the way, you can put a comma and import as many as you want from the same module. And what are we going to do now? Let's leave the lines here for a minute, and let's try to select book. Select book dot value. Okay, let's write that one, and then write book dot. As I said, there are several different ways, right? I'm trying to show you all the different ways. Value book dot select call Okay, so now you have seen the dot notation here and the bracket notation here, and using the call function here, or just passing the column name as a string. Use whatever is most comfortable, but remember the column function is super flexible for advanced transformations, whereas the others are not. So you can use any of these methods to selecting one result you have seen because of the last one. It only shows the result of that one. For example, if I remove this and if I rerun this, it still shows 1. If I go back and remove this, XY, you get the idea. Only last one will be shown. All right. And you might be wondering, well, you didn't call an action. How come it is showing you that? result. Well, you see this? This is the power of this particular configuration. I told it to have this eager evaluation enabled, so it will give me result as soon as it sees each line or transformation. It won't wait for an action. But again, I won't recommend it because you don't need this. You don't want to calculate it. Then you are like disabling the Spark's DAG capability of it trying to figure out everything and optimizing your final query. So don't do that. But there is an option if you wish to see. You might ask me like, when do you want to use this? Well, not in a production code. While developing something, you might want to use this because you want to see the output of each line. Not in a production scheduled application. You don't want to see the output of each application because it will be automated and you don't need this. So only while developing, put this setting, then you can see each one's output. Got it? So now let's look at the data type after splitting and then let's print the schema, shall we? So that is there. Where are my lines? Did I put it here? Even my lines? Okay. Um, that's fine. Let's leave this as is since I already had my code here. Let's pick this and let's move it here and let me run this. Okay. The reason you don't see anything, even if though this is enabled, is you are storing it. It's not like you are just running that. What I can do is I can type lines or run this again, and it will print me the output of the lines. But what I want to see is I want to see are the print the schema of this. So lines dot print schema. Let me run this. And now it is printing schema saying that line is an array and it has an array which has elements of type string. That is true, correct? And by the way, it named the column line because I aliased it. What if I don't alias it? What do you think it will name it? Any guesses? Let me know in the comments. Now, since I didn't alias it, it named it split value, comma space, comma -1. That's what it named it, right? Which is pretty ugly. So the way to fix it is by aliasing it, correct? That's why we aliased it in the first place. And you can also do lines dot show 5 just to see the top 5. That's how it looks like. Okay, we will use alias or with column renamed, that's another function, to set column names you like. We have already seen the alias here, right? And the other way is to use with column renamed. So let's say let's use the same thing. Okay, I'll name this a different one and I will put a bracket. Okay, so that we don't have an alias here, and I will say lines 1 equals to lines 1 dot with column renamed. But in order to do this, you need to know the old column name as well as the new column name. The old column name it gave me previously was, oh, I don't know what is happening here, split value, comma, I think it is a space, I'm not sure, and -1. This is what it named the column, right? When you didn't alias it. So I'm telling it to rename this particular column to this particular column. So let's see if this works. No, it still is showing me that. So let's go ahead and put this. I don't know what that thing is between comma, so I'm not sure. Let's see. Okay, now let's rerun it. And now you have seen it renamed it to line. So I don't know, is it a tab? Two spaces for some reason. Weird. Got it? So this is the another function that you can use with column renamed as well as the split. And remember, always try to use alias inside the select. Whenever you have the select, something like this, use alias and use the with column renamed if you want to rename an existing column. The first time you are doing, alias it. If you for some reason have some other column and want to rename it, then use with column renamed. Now we have a data frame where each row contains a list of words. To analyze the word frequency, we want one word per row. That's where a specific function comes into hand, which is called explode. As the name suggests, it will explode your list into words. Okay, so we can continue using this, and let's say explode. That is another function. I will continue writing that. Yeah, that's okay. Let's leave them as is. Let's use our lines, not lines. So let's do, we are doing splitting, not splitting, but exploding them into words. So let's create a data frame called word lines, select, and what are we doing? We are using the function explode. What is the input for this? The column. Which, what are you exploding? The column line is something that I'm exploding. And again, whatever the output of this, I am naming it. I'm putting that in a column called word. Okay. Now let's say words dot show. Run it. And as you can see, it now nicely exploded them into different words like star into one, start into one, off into one. So as you can see, start of the project, Gutenberg ebook 1344, whatever it is, right? Basically, the explode function flattens the array. This is your array or list. It flattens them, so every word gets its own row. We renamed the new column to word. That's why you can see the new column name as word. Now let's do some data cleaning, shall we? And first and foremost, what I'm going to do is I'm going to convert everything to lower. I mean, you can convert everything to upper, either upper or lower, whatever is consist or whatever is you feel is best for you. But convert them into something uh, same, whether it is upper or lower. And in order to do this, we are going to import another function which is called lower. Now let's do words lower. I mean, actually, oops. Let's leave this just like that and let me write it here. Words lower equals to, again, it's the same. Use the data frame, then do select, and then use the function, and then give the column name, which is going to be word, and rename this. You are getting it now, isn't it? Aren't word. That's it. And then let's print this. Let's run this. So as you can see, it converted all these rows into lowercase, which is good. Now let's do more cleanup. We want only the letters, not something like stars or whatever these empty spaces are. So let's go ahead and remove commas, periods, and other symbols. And how are you going to do that? you are going to do that using another function or regular expressions. You are going to use regular expressions, and in order to write your regular expressions, this is the function you will use. Regexp underscore extract. So I don't know. Can we comment these with hash? I don't want them to be printed out like that. Let's see. Now let's call this words clean equals to words lower, sorry, dot select, and then rich exp, and the input is, you guessed it, the column, and give the column name. What is the column name? Word underscore lower. And this is little bit involved because the regex, it needs the pattern. What is the pattern? You are going to tell that only A to Z means all alphabets, plus means more than one letter. If it matches, then give me only that, and then the final one is 0. And of course we are going to alias this as word. Now we are going to print this out. So anything that is not a letter or alphabet character, it is going to remove them. So let me run, then I will explain you what I'm doing here. As you can see, I mean, we still have spaces. I guess we need to deal with that. But you don't see the stars and etc. So the A to Z plus, it matches one or more lowercase letters. And we use the regex extract to keep just the first group of letters. And you don't need to be a regex expert to use PySpark. Just look up what you want, what you need. You can even use ChatGPT to do that. Okay. And then these are nulls. That's why it is showing that we are going to remove any blank cells which are non-words, which you can see them here. How are we going to do that? And by the way, our hash worked. Double slashes is in, it is in Scala, and PySpark you need to use hash. So what are we going to do now? How do we remove nulls? Sorry, non-null equals to, we are going to use words clean dot, we will filter. We will use the function filter, and let's say select the column where you want to apply the filter on, and I'm going to tell if this is not equal to empty. I want everything that is not equal to empty. Okay, I don't need this, I guess. Then let's say words underscore non-null. No, it's no null, not null. Dot show. Now it should not show these empty ones. And as I said, it is not showing it. It is only showing me the alphabets. So as you can see, this is what is called data cleansing. There are multiple names people use. Data, I guess, munging, which is like reading and cleaning up data, data transformation, data cleansing. No matter what name it is, this is basically what you will do. We use the filter, but you can also use another function called where instead of filter. They do the same thing. Don't get confused. Maybe in some examples I will show, instead of filter I will show where. And to negate a condition, you can use tilde symbol. So for example, I used not equals to. I could totally do this in a different way. Okay, let me write it here. Oops. What is the different way? I could totally put this entire expression in a bracket, and then I can negate it. Shift this one. So, but instead of not equals to, you will put equals to. So when you do this, it is going to pick everything that is empty, which will turn all the empty fields true. And then I'm saying negating it, like give me the opposite of it, false. So it's similar to whatever we did. Instead of putting not here, you can do that as well. And if I run this, it will show you the same result again. Got it? So what did we do here? We filtered after cleaning. If we had done it earlier, our filter expression would have been super messy. Don't you agree? Spark is lazy. It waits to process until an action like show or collect is called. But if you want to bypass that, you can use this one, this particular configuration. And guess what? That's it for this chapter, or not chapter, the episode of your PySpark journey. Let's recap the big ideas. PySpark programs revolve around reading, transforming, and exporting data. Data frames are the heart of PySpark. They are fast, scalable, and easy to manipulate. You learn how to load text, explore its structure and content, transform columns, flatten arrays, clean text, and filter rows. All key skills for real data projects. Don't forget the invisible work, cleaning and prepping data, which is where most of your effort goes, but it makes everything else possible. Try these steps with a different text file or data set. You can go here, there are plenty of data sets here. Okay. Play around with different transformations and filters. I mean, for now, only stick to what I am teaching you. So just use these functions and try your own thing. The more you experiment, the more comfortable you will get. If you found this walkthrough helpful, hit like, subscribe for more hands-on data engineering videos, and let me know in the comments what you want to see next. That being said, have a great day. Peace out and love you all.